guys, got a little SpongeBob action. That was kind of neat and appropriate for starting today. And so we're going to be looking at the graphs of sine and cosine. Briefly, an introduction to graphs of sine and cosine. Very hard for me to teach this in a room by myself with no interaction, but I am going to give this a shot, and this is me doing that. We're going to start with y equals sine x. Just like we learn to graph everything, I would just like to start off with y equals sine x with an xy table. And I'm just going to go around and I'm just going to pick some random values from around my unit circle. Pi over 4, pi over 2, 3 pi over 4, pi. If you haven't quite figured it out yet, I am going every pi over 4 units until I run out of room down here. Now I know that sine of 0 is going to be 0. I know that because of the awesome Kahoot that I did a couple days ago and how well I did on my quiz yesterday. And sine of pi over 4 is going to be the square root of 2 over 2. Whenever I'm coming over here to my graph, though, and I'm graphing square root of 2 over 2, I don't know where that is. So I'm going to I'll be allowed to decimal it out this one time for graphing purposes. So I'm just going to call that 0.7. Sine of pi over 2 is 1. And then I'm going to get 0.7 again. Sine of pi is 0. And then I'm going to get negative 0.7. And then 3 pi over 2 is negative 1. And I'm going to get negative 0.7 again. My handwriting is getting rough down here on the bottom of the screen. You'll have to excuse that. Now I'm going to scale my axis accordingly. I'm not going to be interested in you getting exactly everything in the right spot. So I'm going to call this 1. I'm going to bring this down to negative 1. And then I'll just call every line pi over, I think that works well. Yeah, I'm just going to call every line pi over 4. Now it's going to get really bunched up in here if I put everything on there. And we're going to hopefully get a better way of doing this before the end of the video. So that's going to be 3 pi over 2, 2 pi right there. So if I go through and plot everything that I just found over here, I'm going to get 0, 0. I'm going to get 0.7, and then 1. And then I'm going to get 0.7 again, and that pi, I'm back down to 0. All right, that doesn't look too bad. I'm going to be able to connect those dots pretty easily. And then it's going to come down here and be negative 0.7, and then negative 1, negative 0.7, and then back to 0. And this is known as the first period of sine. This is a cool little wavy line. Now suppose I would have kept on going. All right. I know I left off 2 pi down here, but if I get 2 pi, it also gives me 0. I know good and well if I continue this, if I go to 9 pi over 4, this next line, it's going to be the exact same value as the pi over 4, and then 0. So this wavy line just continues forever and ever in both directions, because even if I was to do sine of negative pi over 4, that would give me a negative 0.7. I was getting these values right off my calculator. So this wavy line just continues in both directions. And that, oddly enough, is what my sine graph looks like. We're not going to label a whole much more than that right there. Okay, we'll get more into that whenever we get into some examples in a minute. I want to talk about the important stuff. The important stuff over here, first of all, I want to talk about the domain. This thing has no breaks in it from left to right. It goes all the way from negative infinity to positive infinity. Okay, the range, the y values, it strictly stays between negative 1 and 1. When we talk about the period of a function or a periodic function, we're talking about how long it takes for the graph to repeat itself. Okay, so if it's repeating itself, it's pretty much after it completes a hill, it completes a valley, and it gets back to where it started. This green part right here would represent one period, and it took me 2 pi units to do that. You're not going to have to worry about symmetry on this. This is something called odd symmetry, where it's symmetric over the origin, meaning that it has rotational symmetry. If I was to rotate this graph that's in the first quadrant 180 degrees, it would match up to what you see on the left side of the y-axis. That is sine. Of course, if you're watching this video, you can go back and rewatch any of this. I know I went pretty fast through that, and you can go back and watch anything that you missed, or you can just jump on and get ready, and we're just going to do all the same stuff we just did for sine, for cosine, to figure out how it is different, so, including starting with my xy table. Now I'm going to try to write a little bit smaller this time, and I'm still going to go up by pi over 4 units. So you might be saying, Mr. Lovelady, why didn't you just leave the xy table and just erase your y values? And to you, I would say, that is a very good question, and I should have done that. Now, plugging, again, if you need your unit circle out, that's fine. Calculator out, that's fine. I'm looking at getting all of my cosine values of all these angles. Meaning if I got my unit circle out, it's all my x values going around. And sure enough, at 0, my x value is 1 on my unit circle. At pi over 4, I get square root of 2 over 2 again. Well, there's that 0.7. That 0.7 worked really well for me last time. At 3 pi over 4, it's negative 0.7. Sine of pi is negative 1. We're looking at all the same values. Hopefully, the graph is going to look pretty similar. The values are the same. They just got mixed around a little bit. So I'm going to come over here and graph all these. Again, I don't have room to put all those marks, all those x values on here, but I think you can kind of tell where everything goes. Okay. So I'm gonna count this as 1, this is negative 1. I'm gonna switch colors so you can really see this graph. It's really cool how it works. I'm just plotting all the points that are on my table. And yeah, it kind of makes a little smiley face. Okay. But again, the unit circle doesn't just stop at 2 pi. I can do 9 pi over 4. I can do 5 pi over 2. I can do whatever comes next. What's that? 11 pi over 4. It keeps going, and it keeps going in the same pattern. It keeps going this way, up and down. It's going to come down here. Keeps all the same pattern. It's very nice and symmetric. And so this would be my cosine x graph. Looks very similar to the sine graph, doesn't it? Biggest thing that I see is the difference between the sine x graph and the cosine x graph is that the cosine x graph starts on a hill right there. Let's talk about the important stuff. Great news, not a lot is changing on this. My domain's still going from negative infinity to infinity. Range is still going to be from negative 1 to 1. The first period of this is going to, let's see, I completed half a hill, a valley, and the other half of the hill. Good news, the period is going to stay the same. The symmetry is going to be a little different. And again, don't get hung up on the symmetry. But the idea of the symmetry on this one is that if it looks at itself in the y-axis, we've got a mirror image going left and right. We call that an even symmetry, or symmetric in the y-axis. Now, unfortunately, on the quiz, the test, I'm not going to give you one that's just, hey, find sine x, cosine x. You know me, I'm going to throw some numbers in there. And those numbers are going to be transformations on the sine x, cosine x graph. Same transformations that we did back in pre-calc A, except I'm not really going to teach it with transformations much past today. And so the first transformation I want to talk about is a period change. What if the period's not 2 pi? If the period's not 2 pi, what's going to happen is we're going to throw a b right here in front of the x. And we have a little formula to help me find what the new period is going to be. And that formula is simply 2 pi divided by b. So if there's a 3 right there in front of the x, great news. The period is going to be 2 pi over 3. I'll show you how we're going to play with that right here. So I'm gonna make one up. I'm actually worked this out ahead of time. I wasn't brave enough. And so I want to come up with, just find the period of the trig function. I want to use y equals, we're going to do cosine of 2x. To be proper, I do need to put that in parentheses. I don't know if any of you is thinking that, but I'm going to be proper on that. So we just graphed cosine x, cosine 2x. It is the exact same as multiplying by 2 on the inside of the function. It's going to be a horizontal shrink. You don't have to worry about doing a horizontal shrink. All right? I'm going to make it so it's as painless as possible. What we're going to do is we're going to undo this by looking at the period. The period is going to be 2 pi divided by whatever's here. So the period in this problem is going to be pi units. Pi units. That means when I graph cosine. May I have your attention, please, at this time? Sorry, we had some interruptions there. Where was I? So remember, whenever I graphed cosine a while ago, I started up here on the hill, right? I had this little hill, and then it came down to -1. See how I'm not paying much attention to my x-axis right there? I'm just making sure I get cosine graphed. And then I can go back and scale my axis however I need to. By the time I complete one period here, by the time I come all the way down and come back up, I should be at pi units. Well, that means if I go halfway back, that this would have to be pi over 2. This would be pi over 4. And then this guy would be 3 pi over 4. And guys, this is all I'm going to need on your graph. My rule is to have 2 hills, check, check, 2 valleys, check and check, and I want you to have your x-axis labeled. All right, I guess your y-axis labeled too. That's it. Let me show you another way of doing that real quick. If you didn't quite get that, let's go back to pi. Let's suppose the period is pi. What I'm going to do is I'm going to come out here, and I'm just going to randomly pick a spot and put pi. I'm going to need to graph cosine, which starts here. And I'm going to need to graph cosine so it comes up and down, and it completes its first full period right there at pi units. Label some on your x-axis. Extend here through the next valley, extend this a little bit so we get the full hill. Right now, this is fine. I'm not going to count that wrong. All right, this is going to be good enough right here just as an introduction. Okay, let me give you one to work. I'll work it with you while you have the video paused, and then when you hit play, we'll go over it. So I would like for you to work y equals sine x. Just kidding, sine of 1/3 x. It's a fraction, no big deal. Go ahead and find the period, mark it, get it graphed, get as much labeled as you can, and then we'll come back and talk about it. Let's go ahead and hit pause and then work it out. Still have some interruptions going. You guys are all leaving school now, so just kind of ignore those. Hopefully you found that the period was 6 pi. And sure enough, what I did was, remember, sine's going to start right here at the origin. By the time I completed one full hill and one full valley, got back to where I started, boom, I'm at 6 pi. All right. So this would be good enough. We're going to get more details on this on the next video. But for right now, this would be something that would be great to practice. Now, one more change I want to talk about, and that's going to be an amplitude change. On an amplitude change, what I'm going to do is I'm going to throw a number in front of sine and or cosine. Okay. So to find out what the amplitude is, and first of all, I guess I need to talk to you about what amplitude is. Amplitude, the definition of it is it's going to be the distance. It's going to be exactly half the distance from the maximum value to the minimum value. I sometimes like to play that definition a little bit, and I'll say the amplitude is the distance from the y-axis to the maximums or the y-axis to the minimum values, okay? Because that would be the same thing. To find amplitude, since we're talking about it being a distance, I do want to use absolute value, and luckily I have the easiest formula for it. It's just simply going to be the absolute value of A. It's going to be the absolute value of whatever I put in front of sine or cosine. Okay, so we'll do one together, and I'll let you try one, and then we'll talk about it. I got so many to choose from. You guys want the fraction one this time? I'll take the fraction one this time. Oh, we'll mix these up a little bit. Y equals 1/3. We'll do the sine one together this time. 1/3 sine x. Now notice I didn't put a period change on this one. So the period's still going to be 2 pi, like it was on the original problem. But this time the amplitude is going to be 1/3. What does that mean? It means that instead of coming up here to 1, this distance is going to just be 1/3. Scale your graphs however you want to, just get them labeled properly where everything goes. And now I know that sine is going to be the one that starts right here at the origin. I come up to 1/3, down to -1/3, up to 1/3, down to -1/3. Try to get everything equally spaced on there, and that's going to be good enough. Okay. Label the x-axis. So I completed one full hill, one full valley, and got back down right here at 2 pi, making this pi. Everything's pretty close to how it was on that first slide, except for there's going to be a 1/3. Instead of going all the way up to 1, it only goes to 1/3. And this will be full credit. Okay. All right, time for you to try one. We'll be about done. One more curveball I want to throw you. Just kidding. We're doing it on this slide. All right. So I'm going to, instead of giving, let's do 4. I'm going to give you cosine. So this is you. We're going to hit pause. We'll work it, and then we'll come back. Hopefully you do something like this. I went ahead and just went all the way up to 4 down to -4. It doesn't matter where you go, as long as you have it labeled. All right. Scale it however you need to. What happens if we just combine our two ideas? Let's do that as we wrap up today, and we'll call that a full video right there. So I've got one here. Let's see. We're going to do y equals 2 cosine of pi x. 2 cosine of pi x. So we got an amplitude change, don't we? We got an amplitude change of 2. And we have a period change as well. Period this time, there's a pi in front of it. Period's just going to be 2. Wow. All right. I think we got this. So that means that my graph is going to come up to 2, down to -2, and it's cosine. Again, I don't want to try to fit a whole period before 2 units. That is going to look really messy. So we're going to scale everything. I like to graph my cosine first. 2 hills, 2 valleys. And look, I'm gonna trace this. I'm gonna go all the way till I complete one full period. Let's see, there's half a hill, and then another half of a hill. I get back to where I started. This distance right there will be 2. Halfway back will be that valley. That'll be 1. Where it crosses is going to be the midpoints. This is good. This is a good graph right there. Everything's clearly labeled. X-axis has enough points on it. I labeled my amplitudes, and we're good. We're going to get some practice on this, and then we're going to add some more numbers to it. All right. So let me know if you have any questions. Good luck. I'll catch you guys next time.